A pleasant day to each and everyone. I'm your reporter for today's video and we are here to report Module 12, which is the wind power system. I'm your reporter number 1, De La Cruz Dan Louis B, together with Aguilar Camille S, your reporter number 2. For the lesson objectives. First, at the end of this lesson, you should be able to identify the components of the wind power system. Second, identify the component of the wind farm. So first, let's define what is wind. Wind is the motion of air in the atmosphere. Movement means that the air has microscopic kinetic energy, in addition to the microscopic thermal energy that comes from the air being at a particular temperature, which can be harnessed by a wind turbine and turned into electricity. This is often referred to as wind power, and the wind is therefore considered as primary energy flow. This is often considered as a form of naturally occurring convection. Generally, movement in the horizontal direction is much more stronger than in the vertical direction. However, both of the vertical and horizontal components of wind has a significant impact on weather. Rising air cools and condenses to form clouds and sinking air warms and dissipates cloud cover. The wind is generally described in terms of horizontal speed and direction. Wind speed can be measured by an anemometer and wind direction by a weather vane. The force of friction and the Coriolis effect both influence wind direction and speed. The wind is formed due to uneven heating of the Earth's surface. These surfaces absorb heat and different rates. For example, sand on a beach can be too hot to walk on while nearby grass feels cool. As these surfaces absorb heat at different rates, the air just above the surface warms and begins to rise. The rising hot air creates a change in pressure in the area. Air naturally moves from the areas of high pressure to low pressure, which causes the horizontal movement of air. For you to understand better, I will give an example for ocean breeze. A practical example is the ocean breeze. The air above land warms faster than air over water. As the hot air over land rises, the cool air over the ocean rushes in to fill the space. The result is a cool ocean breeze. Ocean breeze is designed to be much simpler and cheaper to commission than traditional offshore turbines. With all the commissioning work taking place on shore, all wind turbines operate in the same basic manner. As the wind blows, it flows over the airflow shaped blades of wind turbines, causing the turbine's blades to spin. The blades are connected to a drive shaft that turns an electric generator to produce electricity. When the water of the ocean breeze or the sea breeze comes to the land and make it warm, then turn up to the sun, then return flow to the ocean. Then at vice versa, the cycle will flow, then the turbine will produce more electricity. Wind power. Wind power is the generation of electricity from wind. Wind power harvests the primary energy flow of the atmosphere generated from the uneven heating of the Earth's surface by the sun. Therefore, wind power is an indirect way to harness solar energy. Wind power is converted to electrical energy by wind turbines, while wind turbines use blades to collect the wind's kinetic energy. Wind flows over the blades creating lift similar to the effect on airplane wings, which causes the blades to turn. The blades are connected to a drive shaft that turns an electric generator, which produces the electricity. Wind power is an alternative energy source, like I've said earlier. This means the power of the wind can be used in place of the energy sources such as coal, oil, and nuclear reactions. Wind can be used to produce electricity that heats homes and lights streets and buildings. Wind power is harnessed by a machine called wind turbine. The wind is created by the unequal heating of the Earth's surface by the sun. Next is the wind turbine. Wind turbine extracts the kinetic energy from the wind by slowing the wind down to transferring this energy into the spinning shaft, so it is important to have a good design. The available power in the wind that is available for harvesting depends on both the wind speed and the area that is swept by the rotating turbine blades. So the faster the wind speed or the larger the rotor blades, the more energy can be extracted from the wind. Sinasabi lang dito na sa wind turbine na kapag mas mabilis ang ikot ng turbine is mas maraming energy na ma-extract. So we can say that the wind turbine power production depends on the interaction between the rotor blades and the wind, and it is this interaction that is important for a wind turbine design. A small wind system can be connected to the electric grid through your power provider, or it can stand alone or the off-grid. At the heart of the renewable wind power generation system is the wind turbine. Wind turbine designs generally comprise of a rotor, a direct current, or DC, generator or alternating current, or the AC alternator, which is mounted on a tower high above the ground. Small wind energy systems can be connected to the electricity distribution system. These are called grid-connected systems. A grid-connected wind turbine can reduce your consumption or utility-supplied electricity for lighting, appliances, electric heating and cooling, and vehicle charging. So later we will discuss the main different parts and definition of the main gearbox, generator, drive shaft, and etc. How wind turbines produce electricity. The figure below is the flow diagram of a wind turbine system. What is a wind turbine? A wind turbine is the opposite to a house or desktop fan. The fan uses electricity from the main grid to rotate the circulate the air, making wind. Wind turbine design, on the other hand, use the force of the wind to generate electricity. The wind movements, spin or rotates the turbine, which captures the kinetic energy of the wind and converts this energy into rotary motion by a shaft to drive a generator and make electricity as shown. Wind turbines work on a simple principle. Instead of using electricity to make wind like a fan, wind turbines use wind to make electricity. Wind turns the propeller-like blades of a turbine around a rotor, which spins a generator which creates electricity. So, through this wind is a form of solar energy caused by a combination of three concurrent events. First, the sun unevenly heating the atmosphere. Second, irregularities of the Earth's surface. Third, the rotation of the Earth. How wind turbines produce electricity? Like I've said earlier, we have four main causes. First is the wind turbine. Converts wind energy into rotational or mechanical energy. A wind turbine uses blades to collect the wind's kinetic energy. Wind flows over the blades creating lift similar to the effects on airplane wings, which causes the blades to turn. The blades are connected to the drive shaft that turns an electric generator which produces or generates electricity. Next is the gear system and coupling. It steps up the speed and transmits into the generator rotor. A gear coupling is a mechanical device for transmitting torque between two shafts that are not collinear. It consists of a flexible joint fixed to each shaft. The two joints are connected by a third shaft called spindle. Each joint consists of a 1:1 gear ratio internal or external gear pair. Next is the generator. Generator converts rotational energy into electrical energy. What is electrical generator? It is also called as a dynamo. is any machine that converts mechanical energy to electric or electricity for transmission and distribution over power lines to domestic, commercial, and industrial customers. Generators are also produce the electricity power required for automobiles, aircraft, ships, trains, and even the other electric that uses in the school like electric fan, AC, and etc. And lastly is the controller. Senses wind direction, wind speed, generator output and temperature, and initiate appropriate control signals to take control action. The wind turbine controller consists of a number of computers that continuously monitor the condition of the wind turbine and collect the statistics on its operation. As the name implies, the controller also controls a large number of switches, hydraulic pumps, valves, and motor within the wind turbine. Moving forward for the two basic types of wind turbine, which is the horizontal axis wind turbines and vertical axis wind turbines. So first, let's discuss what is horizontal axis wind turbines. Horizontal axis wind turbines are the most commonly used turbines due to their strength and efficiency. The base of the towers has to be extremely strong, allowing the rotor shaft to be installed at the top of the tower, which allows the turbine to be exposed to stronger winds. With the blades of the turbine being perpendicular to the wind, the rotation of the blades can generate more power compared to the vertical axis wind turbine. As you can see in the blades catch the wind and the spin, and the end of the blades it converts mechanical energy into electricity. At the middle span is the cable carries electricity to transmission line. At the end, the gearbox for the bottom of the wind and spin tower is computer system control direction of the blades. However, the construction of this type of turbine requires a heavy support for the tower to support the weight of the blades, gearbox, and generator, as well as utilizing a sizable crane to lift the components to the top of the tower. But in the Philippines, we have like this tower of horizontal axis wind turbines that we can see in the part of Ilocos Norte. The disadvantage of the horizontal axis design is the tower required to support the wind turbine is much higher and the design of the rotor blades has to be much better. Next, the vertical axis wind turbines. How wind power works for the vertical axis turbines. Vertical axis wind turbines are less affected by frequent wind direction changes as compared to horizontal axis wind turbines due to the blades rotated on the rotor shaft perpendicular to the ground. With the blades and shaft installed in this way, the turbine does not need to rotate the track wind direction. The shaft is mounted near ground level due to the difficulties of mounting the shaft and its components on the tower. An advantage of being mounted at ground level is the maintenance of the turbine is easier and can be installed at locations such as rooftops. Disadvantages to this turbine installation is the efficiency is lower due to air drag and the tower wind speeds compared to the higher wind speeds encountered at higher elevation. This type of vertical axis turbine is also found in the Philippines, which is the Vasco Batanes. How wind powered works vertical axis turbine. As you can see in the figure, we have the upper hub in the top of the vertical axis turbine. Then we have a guy wire and can be formed through the rotor blade, and at the bottom of upper hub we have a lower hub that consists at the bottom of lower hub, gearbox, and the generator. The generator is the main source or the main power to works the vertical axis turbine. However, the wind and the Wind and strong winds can be a source of vertical axis turbine to generate more electricity. And then, various components of wind turbine and its functionality. So, tulad ng sinabi ko kanina sa small wind system, didiscuss ko dito yung function and definition of parts of the small system. So, first we have anemometer. The anemometer, it measures the wind speed and transmits wind data to the controller. So, anemometer is simply tells that it is the kind of device that measures the wind, like temperature and etc. So, this is a mechanical device similar to the regular windmill used to calculate the velocity of the wind. It consists of the axis of rotation running parallel to the direction of the wind. It also has an air vane as the direction of the wind is not constant, helping the axis change its direction. So that's the function of anemometer. Second, we have blades. So blades plays a vital role in small system in windmill. It lifts and rotates when the wind is blown over them, causing the rotor to spin. Most turbines have either 2 or 3 blades. Blades or the wind turbine information. Wind turbine blades are airfoil-shaped blades that harness wind energy and drive the rotor of a wind turbine. The airfoil-shaped design, which provides lifts in a fixed-wing aircraft, is used to allow the blade to exert lift perpendicular to wind direction. So, kung ano yung direction ng hangin, ganun yung magiging direction ng blades. Followed by brake. Brake, it stops the rotor mechanically, electrically, or hydraulically in emergencies. So, yung brake lang yung nagpapahinto kung kailan yung consumption or the pull na yung hangin ng windmill. So, sa pamamagitan ng brake, malilimitahan or hindi sasabog yung windmill. Turbine brakes are not like brakes in a car. So, a turbine brakes keeps the rotor from turning after it been shut down by the pitch system. Once the turbine blades are stopped by the controller, the brakes keep the turbine blades from moving, which is necessary for maintenance. Next is the controller. Controller, it starts up the machine at wind speeds of about 8 to 16 miles per hour mph and shuts up the machine at about 55 mph or miles per hour. The wind farm controller function is the power management. Yung controller is the most power management because it's control the airflow of the air and the advantage of the windmill of its various blades. It can initiate and shut down turbine operation as well as coordinate the operation of numerous wind turbines in response to environmental and operating conditions. The wind turbine supervisory controller manages the individual turbine operation. After the controller, we have gearbox. It connects the low-speed shaft to the high-speed shaft and increases the rotational speed from 30 to 60 rotational per minute or RPM to about 1000 to 1800 RPM or rotations per minute. This is the rotational speed required by most generator to produce electricity. So yung most commonly required speed is the 1000 to 1800 RPM. So kapag bumaba sa 1000 or 800 to 1700 RPM, hindi ito makapag-produce ng electricity. A gearbox is costly and heavy. So mahal daw yung gearbox. Part of the wind turbine and engineers exploring direct drive. Generators that operates the lower rotational speeds and don't need gearboxes. So yung mga lower rotational speed is hindi na minsan kinakailangan ng gearboxes, but yung most commonly windmill in the Philippines is ginagamitan ng gearbox. A gearbox is often used in a wind turbine to increase the rotational speed from a low-speed main shaft to high-speed shaft connecting with an electrical generator. So gear in a wind turbine gearbox are subjected to severe cyclic loading due to variable wind loads that are stochastic in nature. Next, we have generator. Generator produces 60-cycle AC electricity or alternating current electricity. It is usually an off-the-shelf induction generator. So the generator is driven by high-speed shaft. Copper windings turn through a magnetic field in the generator to produce electricity. Some generators are driven by gearboxes, and other are direct drives where the rotor attaches directly to the generator. So yung generator is most attaches or the connected to the gearboxes na sinabi ko kanina. Yung generator is also the main source of windmill and plays a important role in para mapagana yung windmill. Next is the high-speed shaft. Yung high-speed shaft is part of lang ng gearboxes, but it drives the generator. Part of the turbine drive train, the high-speed shaft connects to the gearbox and drives the generator. Yung tulad ng sinabi ko kanina, yung high-speed shaft is part lang ng gearbox, but it plays like a good or important in the windmill. The high-speed shaft drives the generator, which produces AC electrical current or the alternating current. Power cables transport the electricity to ground level. An anemometer measures the wind speed and transmits wind speed to the controller, and controller starts the wind turbine at speeds of about 12 to 25 km per hour. So yung controller daw is nag-starts ng 12 to 25 km per hour. So diniscuss ko nga kanina kung ano yung controller. Sa high-speed shaft is also connected to the anemometer. So kung ano yung value ng nakukuha sa high-speed shaft, like the 1,000 to 1,800 kpm na sulat ng sinabi ko kanina, is na-measure din sa anemometer. So kung may high-speed shaft, merong low-speed shaft. So low-speed shaft, it turns the low-speed shaft at about 30 to 60 rpm. Part of the turbine drivetrain, the low-speed shaft, is connected to the rotor spins between 8 to 20 rotations per minute. So sa sa 80 for 20 rotations, meron daw na nagaganap na 80 to 20 rotations kada minuto. So kapag may isang oras, marami ng 1 hour is 60 times 80 to 20 rotations na magaganap. So medyo mabilis na rin yun kaya makakapag-produce na ng konting electricity. Low-speed shaft turned by the wind turbine rotor. So sa gearbox, part din ng low-speed shaft tulad ng high-speed shaft. So yung gearbox used to transfer rotational mechanical energy from the low-speed shaft to the high-speed shaft. High-speed shaft driven by the gearbox output coupled to the generator and drives the generator. So yung gearbox is made to two main parts ganun. High-speed shaft and low-speed shaft that describes or measures the speed of the windmill that helps for it to generate well and hindi magsasanhi ng kahit anong anomalya, like pagkasira ng windmill that pwedeng bumagsak yung mga blades dahil sa maling high-speed shaft and low-speed shaft. So for the other parts of small system or the windmill, we will discuss of the second reporter, which is Camille Aguilar S. from Main 2 also. Discuss niya yung other parts and various components of wind turbine and its functionality, definition, and how it works and affects the windmill.
Moving forward to letter I, which is nacelle. Nacelle, it sits at the top of the tower and contains the gearbox, low and high-speed shafts, generator, controller, and brake. Some nacelles are large enough for a helicopter to land on. So, regarding sa component na ito, it is simply located at the top of the tower of a wind turbine, and consists of the gearbox, low and high speed shafts, etc. Or what should I say is, it is the cover housing that houses all of the generating components. Next one is pitch. Turns or pitches blades out of the wind to control the rotor speed, and to keep the rotor from turning in winds that are too high or too low to produce electricity. Okay, pitch. This component plays an important role as it is to control the rotor speed, and by that, it adjusts the angle of the wind turbine's blade with respect to the wind, and then, by adjusting the angle of a wind turbine blades, the pitch system controls how much an energy of the blades can extract. Then, rotor. It's the main part of a modern wind turbine design that collects the wind's energy and transforms it into mechanical power in the form of rotation. The rotor consists of two or more laminated wood, fiberglass or metal rotor blades, and a protective hub which rotates around the central axis. So, rotor is simply for the wind turbine that turns the wind energy into electricity using the aerodynamic force from the rotor blade. Then, tower. It supports the structures of the turbine because when the speed increases with height, taller towers enable turbines to capture more energy and generate more electricity. Made from tubular steel, concrete, or steel lattice. So, these components serve as support to the structure of our wind turbine, and the taller tower is the more energy to attain and will result to generate more energy. Also, tower is made out of tubular steel and concrete. Next is wind direction. It determines the designs of the wind turbine. Upwind turbine like the one shown here face into the wind while downwind turbines face away. So, wind direction merely determines the design of a wind turbine. And, for instance, if it is a upwind turbine, therefore it is facing into the wind. Then, wind vane. It measures wind direction and communicates with the yaw drive to orient the turbine properly with respect to the wind. So, wind vane is used for showing the direction of the wind, and also vanes comes from the Old English word fana, which means flag. Next, yaw drive. It orients upwind turbines to keep them facing the wind when the direction changes. Downwind turbines don't require a yaw drive because the wind manually blows the rotor away from it. So, these components is to ensure that the wind turbine is producing the greatest amount of electric energy, and it is also used to keep the rotor facing into the wind as the wind is changing its direction. Then, yaw motor. It powers the yaw drive. So, yaw motor is simply to provide a power to the yaw drive. And as the slide shown, it is the different components of a wind turbine completely. So now let's proceed to blade number. Generally, three-bladed turbine rotors integrate better into the landscape, are more aesthetically appealing, and are more aerodynamically efficient than two-bladed designs, which contributes to the fact that three-bladed wind turbines are more dominant in the wind power generation market. Although certain manufacturers produce 2 and 6 blade turbines for sailboats, other advantages of a three-bladed rotors include smoother operation, less noise, and fewer bird strikes, which compensate for the disadvantage of the higher material costs. Noise level is not affected significantly by the blade count. So So, the wind turbine blade is an important component of a clean energy system because of its ability to capture energy from the wind. And the number of blades affected the rotation of the wind turbine. The number of the blades is very important because it affects the speed and efficiency of turbine. Thus, few numbers of blades results in a poor efficiency and it may fall with an inadequate performance. Next one is rotor blade length. A turbine's rotational speed is defined as RPM is equals to wind speed times tip speed ratio times 60 over the diameter times pi. So, the longer the turbine blade length, the faster the rotation of the tip for a given wind speed. Likewise, for a given rotor blade length, the higher the wind speed, the faster the rotation. We cannot have a wind turbine design with very long rotor blades operating in a windy environment producing lots of free electricity from the wind, because there is a point where the length of the rotor blades and the speed velocity of the wind actually reduces the output efficiency of the turbine. This is why many larger wind turbine designs rotate at much slower speed. So, as larger rotor diameters will allow the wind turbines to sweep more area, capture more wind, and produce more electricity. Thus, a turbine with longer blades length will be able to capture more of the available wind than the shorter blades, and even in areas with relatively less wind. So next is rotor blade pitch angle. Fixed design wind turbine rotor blades are generally not slick or flat like airplane aerofoil wings, but instead have a small twist and taper along their length from the tip to the root to allow for the different rotational speeds along the blade. A straight or flat rotor blade will stop giving lift and may even stall if the rotor blade is hit by the wind at different angles called the angle of attack, especially if this angle of attack is too steep. So, rotor pitch controls to adjust the blades in the wind turbines by rotating them so that they use the right fraction of the available wind energy to attain the most power output. In addition, changing the angle of the blades will change the area facing the apparent wind, and that's why blade pitch angles of 10 to 20 degrees tend to have much less drag than greater angles. Next is wind power plants. Wind power plants or wind farms are clusters of wind turbines that produce large amounts of electricity. A wind farm usually has many turbines scattered over a large area. So, wind power plants is a power generation that converts wind energy into electric energy. Additionally, wind turbines may also reduce the amount of electricity generation from fossil fuels that results in a lower total air pollution and carbon dioxide emissions, which is really beneficial in our environment. So now, let's proceed to the parts of the wind power system. And as you can see, the pictures depicts the different parts of our wind power system, which is really helpful in protecting our Earth's nature. That's all. I hope that you've learned our lesson objectives today. Then I will end this report in a quotation of Gloria Ruben that says, "A transition to clean energy is about making an investment in our future."